The Being an Engineer podcast is a repository for industry knowledge and a tool through which engineers learn about and connect with relevant companies, technologies, people, resources, and opportunities. Enjoy the show.
I was listening to a couple of your podcasts. I was like, this podcast is a great way to get some exposure because I noticed you have a bunch of different engineers, some with the same discipline type, who are all doing very different things. And maybe that's a good exposure to understand the various career paths that are available.
Hello everyone, welcome to the Being an Engineer podcast with your co-host Rafael Testay. Today we have another very special guest, Kristy Walson. She's a mechanical engineer by trade and a sustainability consultant by nature. She specializes in engineering, energy modeling, energy audits, utility analysis, and sustainability consulting from conceptual design through occupancy. She's abnormally excited about energy reduction in existing buildings. And what really attracted me to have her as a guest on the show is, as you heard, her background, her degree is from Virginia Tech and mechanical engineering, but right now she's designing buildings. So I'm very interested in that transition. Kristy, welcome to the show.
Thank you for having me.
Of course. So we'd like to start out by asking, how did you decide to be an engineer?
Oh, goodness. Well, it was a bit of a circuitous path for me. Anyway, I think it is this way for a lot of engineers. I early on was always inclined towards STEM, so that inclination was there. I like to build things with my hands. My dad was a big kind of handyman, used tools. I knew how to use tools at a young age. So there was that part of it. And when it came time to decide what I was going to do for college, I went back and forth between a few things and finally landed on engineering and mechanical engineering because primarily it's probably the most flexible engineering. There's a lot of options, although many different pathways have a lot of options. So I went to Virginia Tech, got a mechanical engineering degree, and then you have to decide what you're going to do for the rest of your career at the end of college. And, it's not always clear what all the pathways are. Sometimes, you're kind of just on this headlong, I'm going to graduate, and then realize, oh, I have to do something. So I had grown up on a boat and decided to go get a master's degree in marine engineering and naval architecture from the University of Michigan. So I have that master's as well, and I worked in the marine industry for about 7 years out of college. And it was fun and lots of hands-on stuff, and, I love boats, but there was something missing for me. I'd always been very environmentally conscious and sustainably minded, but it didn't have a name when I was in college, and it wasn't a major when I was in college. And I was sitting there one day reading a magazine and learned about the LEED rating system, which is a sustainable certification that's basically the most widely spread sustainable certification at this point. And learned that engineers were doing things to help buildings get LEED certified. And it was kind of like a light went off, and I was like, oh, this is what I want to do. And I hadn't been seeking another career, but it kind of just happened that way. And kind of one thing led to another. I joined the local U.S. Green Building Council chapter, made contacts there, and got a job offer at TLC, which is one of the leading sustainably minded engineering firms in the country, and happens to be headquartered in Orlando, where I was. And that was 15 years ago. The rest is history at this point. But that's how I ended up becoming an engineer.
What a wonderful story. There's one thing that stood out to me because there's a lot of young listeners that are still in college trying to figure out what they want to do for the rest of their lives. And even older people, the journey never ends. We may want to change in a direction as to what we're doing with our careers. And I'm thinking about the magazine that you were reading, and maybe in today's day and age, maybe it could be an article online, how everything's online now. But maybe the take-home point is you want to expose yourself to lots of ideas and technologies that are being developed to see if something resonates with you. Would you agree with that?
I totally agree. And actually, as I was listening to a couple of your podcasts, universities do a great job of educating and preparing students for earning their degree and for what may be coming in their career, just giving them the tools in the toolbox to perform the tasks that are needed. But they don't necessarily do a great job of telling graduating seniors, what job opportunities are available. A lot of mechanical engineering students don't even realize that HVAC design, which is the mechanical design of a building, is a very accessible pathway to available to them as a mechanical engineer. So, I think that exposure is definitely critical. And I was listening to a couple of your podcasts. I was like, this podcast is a great way to get some exposure because I noticed you have a bunch of different engineers, some with the same discipline type, who are all doing very different things. And maybe that's a good exposure now in the day of podcasts, to understand the various career paths that are available.
Yeah, well, thank you for the shout out while being on the podcast. I agree with you. Please, so our listeners can look up online. You said the mechanical design of a building. What's the name of that?
Well, it's HVAC design. So you're designing the air conditioning, the cooling, and the heating systems in the building. And you're also largely in charge of the controls in the building, which is the building automation system. And that is basically our primary ubiquitous tool for energy savings in buildings right now. There's other means to energy savings, but the controls at the end of the day cause the building to operate when it's supposed to operate and to not operate when people aren't there. And that's all part of the mechanical engineer's design.
Very interesting. I am one of the people that she mentioned that wasn't aware that a mechanical engineer can do this.
Yes.
No idea that was the case.
I didn't either.
I'm wondering, what kind of magazines do you read nowadays, or do you recommend people would read or blogs so they can expose themselves to more in addition to this podcast?
So, I guess it depends on what phase of your life you're in and what time you have available. For me, it's podcasts are the amount of time commitment I'm available to put to something. So I would go, research and look for possible podcasts to listen to. But I think primarily the internet, it's so widespread in its available access to information. And I think even just the mere Googling, what career paths are available to mechanical engineers, that could get you down the right road. It's all about adding information that you didn't have before, right? So now that you know that HVAC engineering is a thing, it's in your brain and it's an option. It's all about just building that list of options that you have and then going with whatever resonates with you.
Yeah, I agree. It's like a mental library of career opportunities.
That's right.
Okay. Well, actually, my first major in college, before I chose molecular biology and genetics, my degree, my first major was sustainability. And
fabulous.
I see a lot of sustainability. Yeah, I see a lot of the word sustainability in your your LinkedIn, and the first class in sustainability, they will always define the first slide, the word sustainability, what it means. Could you define it for us?
Well, it's changed over time. I will say that. And the terminology that we use in the sustainability world has evolved over time. So in general, when I use the word sustainability, my intent is to reference doing things. So whatever the thing is I'm talking about, let's say HVAC design or building design, doing that in a way that reduces and optimizes all of the things that you need to use to make that building. So you're going to use energy, you're going to use water, you're going to use materials. Those are the three big things that go into a building. And, you can't use zero energy in a building. You can offset your energy with renewable energy and become net zero, but a building has a purpose, and that purpose requires power and energy. So using the word optimize is what I like to say. So to me, sustainability would be optimizing the uses and the materials that go into a building in my line of work to make that building have the least amount of impact on the environment as possible. And then if the owner or the developer or whoever is really committed, then offsetting the remaining use. So the energy that you're using, offsetting that with renewable energy. If it's water, consider rainwater harvesting and using non-potable water for certain applications. And really optimizing and then offsetting the impact of that building.
Okay. What has given you the most sense of pride or fulfillment from a building design job that you've done?
So, for me, because I have kind of shifted gears here in the last few years and have moved my thinking from less of a micro building by building perspective to a more macro global warming, climate change perspective. To me, the buildings that have the most square footage that I'm able to impact are the most important ones for me. Because at the end of the day, buildings use a very large amount of energy, and they're a high percentage of the emissions that goes into the carbon emissions and the global warming that does create climate change. So I worked on, and I'm still working on, our it's Orange County Convention Center. It's over 7 million square feet of conditioned space. TLC, my group within TLC, got the lead for existing buildings and operations and maintenance certification for that building. We were the consultant that did the work to get that building certified. And we continued to be a consultant for them. We just wrote their sustainability action plan. And so that's one project that I'm most proud of. I would say the biggest point of pride for me, though, is my work with the University of Central Florida. They're a top 5 in student count university in the country. They're located here in Orlando. We work very closely with them. We do a lot of their designs. We also do a large amount of their sustainability consulting. I've been the lead facilitator on almost 20 buildings that are LEED certified just for them. So, and they are walking the walk, and it's a pleasure to work with them. And they're currently working on some even bigger things right now that are going to have a really big impact, I think, on our area and on our region.
So you're the first person that, like I said, that I met that's doing this. And I wonder, from your mechanical engineering degree, where we learned the free body diagrams, the thermodynamics, the calculus, the CAD, do you use any of that math that I just mentioned or physics in what you do daily now or no?
Every day.
Every day. Good. That makes me feel better, because I'm working on getting my second degree in mechanical engineering, and I'm going through all the classes I mentioned. How do you use what I just explained every day? Any insights you could give us?
Absolutely. So HVAC design, all those things you're learning in thermodynamics and fluid design are HVAC design. And so we use a lot of thermodynamics in HVAC and mechanical design in order to get calculate the load, the heat load in the space, so we know how much cooling needs to go into it. And so that would be us coming up with a load calculation, right? To size our equipment that goes in the building, size the air handling units and the things that cool the air and heat the air. But what I do is I take it another step further, because those items, load calculations and equipment sizing, those are all done with the peak scenario in mind, the worst case scenario, worst case for cooling, worst case for heating. But the actual operation of the building doesn't operate at peak all the time. So what I do in my field on the sustainability side is we then take that design and we create an energy model. And we use the energy model as a tool throughout the design process to inform the design engineers how to optimize the systems in the building to bring the energy use down and really make this a smart building, not just a building that runs on peak. And that's the operation of a building is where the energy use comes from, not necessarily the peak design. And as I mentioned earlier, I think the controls of the building automation system that goes into the building, a simple example is if you have a Nest thermostat, that's a building or that's a control, right? So you can set it, put schedules on it. If it's smart, it'll sense your, motion and turn on the air handling unit to occupied mode when you're around. It'll learn your patterns. These are all the things that a building automation system can do. And these are all the things that you want the building automation system to do to reduce the energy use in a building. So I use that real world data to create an energy model from our design and anticipate the energy use in that building, then inform the team how to bring that energy use down to an optimized number.
Very well explained. This is a good moment to remind our listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering. Pipeline partners with medical and other device engineering teams who need turnkey equipment such as cycle test machines, custom test fixtures, automation equipment, assembly jigs, inspection stations, and more. You can find more on the web at teampipeline.us. I'm here with Kristy Walson, and I want to follow up on what she was just saying. What are maybe the 3 top softwares that you use for all these calculations that you use?
Sure. So for the heat load calculations, a real popular software that we utilize at TLC is the Train Trace software. It's actually developed by Train, which they manufacture and provide commercial HVAC equipment and residential HVAC equipment. So, it is developed by the vendor, but it's proven to be a very reliable heat load calc platform. And then on an energy modeling side, we utilize IES VE Pro for our energy modeling software. It's the capabilities of IES are very heavily weighted toward the controls in the building, which, like I was saying, is where you fine-tune your system. So that's part of the appeal of using VE Pro. We have in the past as well, and sometimes if I need to do a real quick look, used eQuest, which is a free online tool. The only downside about eQuest is that it's a government-funded tool, and if there's no funding, it doesn't get updated. Its capabilities are there, though, for most systems, and so it's an easy way to do a kind of a quick sanity check on a design or a potential design.
Okay, Very good insights. Well, when I went to college for my first major, I only did one semester, which was sustainability. One of the main reasons why I didn't follow through with sustainability was that every sustainability class that I went to, it was very sad, very depressing, because the professor would say, this is the current status of the planet. All the animals are dying. Look at all of our consumption. End of class, bell rings. And I'm like, okay, what are we going to do about this?
Right.
And they're like, well, just write an essay about how bad things are. And that's all we ever did in all the classes. So I said, I can't take this anymore. I'm a solutions person. Did you ever feel something like that?
Well, first, that's just sad.
Yeah,
that's
it was
a sad state of affairs. Now, those of us in this industry, in the sustainability industry, don't get me wrong. We have our moments where we're like, oh my gosh, the icebergs are melting. All the polar bears are dying. We can't do a thing about it. What are we doing? But it's, I think engineers are almost an ideal scenario for tackling climate change and tackling sustainability in a way, because we do have that functional, logistical way of looking at things. And so, I'll have those moments, but I'm able to set them to the side and forge ahead. And, those moments also help you reframe what you're doing and if you're doing the right thing, right? So, and then I have to say this, I have 3 children, 3 boys, and I teach them about sustainability and energy as well, because, I can do stuff in my career. And as I grow, my reach grows and expands. But there's nothing like teaching the next generation how to functionally and logistically mitigate climate change as they move through the world. It doesn't have to be about guilt, and it doesn't have to be about all the things that you don't have control over. It's about the things you do have control over and the message that you can spread. So I do, there are those moments, believe me, but we all have them. Whether or not you're in sustainability, I think everybody has those moments. So we get past them and we keep doing the work.
That actually is a perfect segue for my next question, which is, how can the engineering community as a whole contribute to climate action? This is your chance to tell everybody.
This is it. This is my moment. I am very excited with this moment. Thank you for the question.
It's all led to this. Yeah.
It's all come to this. So the engineering community has immense power in this fight against climate change, mitigating climate change. And the reason is we get to touch all the systems that have a very large impact on climate change in general. So if you look at a pie chart of all the things that contribute to climate change and to carbon emissions, because it does mostly all come down to carbon. There's other greenhouse gases, but carbon is something like 85% of the greenhouse gas emissions contributing to climate change. And I'm going off memory here, so let's just go rough numbers, about 40% of that whole greenhouse gas emission number is building operations. So all of our old buildings operating incredibly inefficiently, the new buildings that we build without energy in mind, those are all adding up to about 40% of the problem. And then another 11 to 12% is in the manufacturing of building materials. So surprisingly, and then the other parts of the pie are industry, and as you can imagine, fleet. So like cars on the road and things like that, because that's the picture we always envision when we think of carbon emissions or cars on the road. But between the building operations and the building materials, we're over 50%. And the industry that I'm in, the AEC, architectural, engineering, and contracting industry, the construction industry, it has the ability to make decisions surrounding that 50% or slightly over 50%. So between the materials that go in the building and the amount of energy that a building uses and the types of systems that we put in, the amount of lighting we put in, and even the choices on a holistic scale, do we really need a new building or can we utilize an existing building? All have an incredible impact on that 50%. And so, we have the innate power to be, first and foremost, good advocates and consultants in this arena, in this energy arena. We have the ability to, largely what happens is the architect is designing the building and we are reacting to the design of that building with our systems, but we have the ability to turn around and advocate for more energy efficient design on the architectural side, different selection of materials on the structural side. And when you look at the pie and that 50%, that's just such an enormous opportunity to reduce carbon emissions. Wonderful.
Okay, so now all of our engineers, we know what to do to contribute to climate action. My last question of the podcast, we want to clarify. So TLC is the company you work at, correct?
That's
correct. So what's TLC's process for optimizing energy use in their designs?
Sure. Yeah. So first and foremost, early energy modeling. We like to do an energy model before we even know what ideally before there's even an idea for a building. We generally know the square footage that's needed to accommodate the programming that the owner has developed. And we have an idea for the space, maybe that it has to go in, like if they have a land already and they know how much acreage they have. But in an ideal world, we would be able to do an energy model and run various iterations and ideas in the design before that building has even really been conceived and thought about too much. And that gives us the opportunity to present ideas that aren't within the box of design a lot of times. The reality is that we typically, as engineers, do not get involved in a project until after at least a schematic rendering or an idea has happened for this building on the architectural side. So then we take that and do an energy model real quick. You do not have to have all the information to do an early energy model. You can do it based on very, very early data, and you run iterations and provide the design team a roadmap for their design. I also like to hold an energy charrette when the project timeline allows for it, to have all the consultants, including the owner, in the room to discuss ways to reduce energy. It's amazing how productive a meeting like that can be when we all get together. It's the power of collective knowledge, in a room together. Typically, we walk in thinking this building and the systems are going to look one way, and we walk out and they look a lot different when we leave, when you take energy into consideration. And then we like to hold the design accountable. So we've created this roadmap, and as the design progresses and the various drawing milestones go out, we update the energy model and hold the design accountable for the energy target that was created in the energy charrette. And if it doesn't hit it, we come back to the table and we have a conversation about, what happened and then what can we do to bring the energy use back down to our target number. And ideally, after the fact, once the building's built and occupied, we would go back and calibrate the energy model one more time for the actual occupancy of the building. That tends to happen less than I would like, because once the building owner is in the building, they're running their business, and they've got other things in mind, they have to run their business, and it's not engineering or energy optimization. So, but where we can, we like to come back in and calibrate that model to validate the design and what we designed actually accomplished the goal.
Wonderful. Well, it's been a pleasure having you on the show. Are there any last words for our audience they'd like for them to know?
Sure. Well, if you're thinking about being an engineer, it's a very fulfilling career path, at least for me. And, I don't think anyone 10, 20 years ago would have anticipated an engineer being in sustainability or environmental, systems. So there are so many paths that you can take. An engineering degree opens up the, bigger picture. But also, my final takeaway would be, as you are designing, keep an eye on the holistic side of things. Keep an eye on how does this impact the greater community and climate change and energy and all those things. Because when you take the holistic view in mind, you're always going to end up with a better design at the end of the day.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.
Dear valued listener, we kindly ask that you help us get to 100 5-star podcast reviews in the platform of your choice. For a chance to win a $50 Amazon gift card, send a screenshot of your 5-star podcast review to podcast@teampipeline.us. You'll find that email address in the description of the show notes.